In the previous video, we looked at building a regression classifier to classify our learning points. In this video, we're going to take a look at the use of Bayes' theorem to build a naive Bayes classifier. A naive Bayes classifier is a supervised learning classifier that uses Bayes' theorem to build the model. Let's go ahead and build a naive Bayes classifier. Now, here we will use naive Bayes.py that's provided to you as reference. Let's now import a couple of things like Gaussian NB from naive Bayes and plot classifier from logistic regression. You are provided with a data multivar.txt file. It contains data that we use here. This contains comma-separated numerical data in each line. Let us first load the data from this file. So here we have written the code to load the data. So now we have loaded the input data into X and the labels into Y. Next, let's build the naive Bayes classifier. The Gaussian NB function specifies Gaussian naive Bayes model. Now let's compute the accuracy of the classifier and print it. Then let's plot the data and the boundaries. Now let us run this code to see the output. So now you should see this output on your screen. Great! There is no restriction on the boundaries to be linear here. In the preceding example, we used up all the data for training. A good practice in machine learning is to have non-overlapping data for training and testing. Ideally, we need some unused data for testing so that we can get an accurate estimate of how the model performs on unknown data. There is a provision on scikit-learn that handles this very well, as shown in the next video. So we got the accuracy of the model and the output, as you see on the screen. In this video, we built the naive Bayes classifier to construct non-linear boundaries to classify our learning points. In the next video, we'll split the dataset for training and testing.